good morning, good afternoon, or good evening, whichever is applicable to you, and thank you for joining us for today's webinar titled Generation Datasets, Unique, Useful, Understandable. ZOS systems use a variety of specialized file types that can look unusual to those new to the mainframe. From partition datasets to vSAN files, these formats play a unique role in managing data. Even seemingly ordinary sequential files behave differently in ZOS, and one of the most powerful examples is the generation data group. With a history predating DFSMS, GDGs often house an organization's most important files across both disk and tape. We'll break down how GDGs are created, their key attributes, and how applications make use of them, giving you the knowledge to confidently manage one of ZOS' most enduring and essential datasets. This presentation is sponsored by Precisely Software. Precisely is a recognized global leader in enterprise data integrity products for mainframe, mid-range, and distributed systems. For more information on Precisely, please visit www.precisely.com. Our speaker today is Principal Technology Architect Steve Pryor. Steve has more than 30 years' experience in storage management, design, and support, and speaks frequently at industry events. Prior to joining Precisely, Steve made important contributions at several mainframe software vendors, designing and implementing major products and components. At the end of the presentation, we will have a short Q&A session. Attendee microphones are muted for the presentation, but you may ask a question or request webinar assistance at any time during the webinar through the Q&A interface. After the webinar, all registrants will receive a link to the slide deck and recording. Thank you again for joining us today. Take it away, Steve.
Thanks, Ray. Good morning, everyone. My name's Steve Pryor, and welcome back to the next iteration of what was the DTS software introductory webinar series, and is now being continued under Precisely. And so you'll notice the slides have a little bit more purple tinge to them. But we're going to continue with our goal of trying to disseminate information about ZOS, first of all, to users that might be new or somewhat new to the ZOS system, and hopefully at the same time maybe add some tricks and tips that might be useful even if you've been doing ZOS system programming or ZOS programming in general as long as I have. Which is something on the order of actually 45 years now, so we have to update our intro a little bit. But today I want to talk about generation datasets, which is, as the title says, it's a unique way of dealing with data. It's unique to ZOS. You're not going to run across generation datasets or generation data groups in your garden variety Linux system, or indeed in just about any other system. You may run across things that kind of look like them and kind of act like them, but the generation data set really is something unique to ZOS. It's particularly useful for things like tape data, large volumes of data. It's used widely for backups. And as far as the last U in the title, they actually are pretty understandable. They're really quite logical, and they've had a lot of features to them, like everything else in ZOS had a lot of features added to them over the years. And so we'll talk about generation data sets and generation data groups. And so as we do that, it's important to understand the difference between a generation data group and a generation data set. A GDG is a catalog entry. It's a piece of metadata that allows us to keep track of a bunch of data sets, presumably containing related information, but a group of related data sets that have the same information usually over a period of time. Things like SMF records that might be stored on a daily basis. Things like backups that again are performed on some sort of daily or weekly basis. Where you don't want to have to change the name of the file every day. You can use the same naming convention to reference all of the data sets or any individual data set within the generation data group. So this allows us to not have to change the JCL to automate the way that the data sets are dealt with. And so we've got a generation data group, which is an entry in the ZOS catalog. And the ZOS catalog, of course, is really the keys to the kingdom in ZOS. It keeps track of every data set in ZOS. It keeps track of a bunch of other things in ZOS besides individual data sets. And one of the things it keeps track of is the generation data group. That is the group of data sets that are going to be treated together as a group. We create a generation data group by IDCAMs, program IDCAMs, which of course is used for any sort of access to the catalog. Typically, IDCAMs, you think of listcat, think of listing a catalog entry, or perhaps creating a VSAM data set with an IDCAMs define. There's a define for generation data group to create a GDG called IDCAMs, well, program IDCAMs define GDG, and this creates what in the catalog is called a sphere record. That is, it's a record, a metadata record that contains pointers to other records. There are sphere records for VSAM because the VSAM cluster is defined in the catalog, and the VSAM cluster contains a number of components. Similarly, a GDG, which is a catalog type entry B, and there's also another type J, but type entry B is each entry in the catalog has a particular record type, and so type B is a generation data group, and it defines the generation data group name. Obviously, this is my weekly backup or my daily SMF, and the number of generations that are currently kept track of. And the generations, when we refer to actual generations rather than the generation data group, then we're talking about the generation data set, which is really, normally it's an ordinary sequential data set. It could be tape, could be disk, could be SMS, could be non-SMS. The generation data set is very flexible. It's any sort really of sequential data set. Or actually, it could be a partition data set. It could be a PDS or PDSE or a BDAM file. But it's an ordinary sequential data set. It has a little different catalog entry record, a type H rather than type A or a type D, whatever the type record might be for an ordinary sequential data set. So you can mix and match, although it's probably not the best practice. You can mix and match generations or generation data sets within a generation data group. So I could theoretically have some generations, some data sets that are PDSs, some that are PDSEs, some that are on disk, some that are on tape, some that are SMS managed. Probably not a good idea if I want to really manage them as a group, but it is possible to do that. The only thing you really can't have is a PDSE member, or excuse me, PDSE member generation, because there's a restriction in the JCL that you can only have one thing in a set of parentheses. So these may have the same, all the data sets within, all the generation data sets belonging to a generation data group could have different attributes. Some of them could be LRECL 80, some of them could be fixed blocks, some of them could be variable block. But normally, since you want to deal with these records as a group, normally you give them all the same attributes. My backups are always rec form U. My SMF records are always, DSORG equal PS. So normally you deal with them as a group. But the generation data set is any single data set belonging to the generation data group. The generation data group defines what range of data sets are going to be treated as a group. And so what are the advantages of using this? Well, the data sets in a generation data group, that is all of the individual generation data sets, can be referenced using the same name. So I don't have to make changes to JCL. I don't have to have a Wednesday data set, a Thursday data set, a Friday data set. I can just use the same name and refer to a different generation, because the catalog takes care of creating the next generation, naming the next generation, keeping track of it in the catalog. As we said, they're very flexible. We can have disk and tape data sets, and we can scale this up to, we can have up to 9,999 generations belonging to a generation data group at any given time. That's probably a little excessive. There is a limit to how many you can have cataloged in the as part of the active generation data group, but the actual generation number, which increases as you create new generations, can be up to 9,999. This doesn't mean you're limited to 9,999 generations. You can have more generations than that. It's just a matter of keeping track of them may be a little more involved. And the data can be accessed in chronological order, either forwards or backwards. We can get all of the data sets in a single, all of the generation data sets in a single reference by just specifying the GDG base name, or we can reference them one at a time. And we can reference them individually, or we can reference them relative to the current generation. And as I create new generations, older generations can be rolled off, and we'll talk about how that works. So we've got the GDG base name, which is up to 35 characters. And then to create a generation data set name, that's going to be followed by an 8-character fixed sort of name where G and V are always present. And then a generation number, which can be from 0000 to 9999. Actually, it can only be from 0001, never create generation 0. And then a lot of people aren't aware of this, but you can actually have multiple generations with the same generation number. I can create generation 10, generation 20, generation 30, and I can take one of those, generation 10, and I can have version 1 and version 2. If I have a different version number, so if I have G0010 for generation 10, V00, version 0 is the normal GDG name, I could create V01. Only one of those can be cataloged in the generation data group at a time. But if I want to replace a generation data set with a different version, I can do that merely by uncataloging one entry from the catalog and recataloging the other one. And so it's not used very often, but you can, with the absolute name, specify a different version other than version 0. So how are these accessed? They're accessed by absolute generation version number or by relative generation version number. And so this particular slide I actually stole from using data sets, or actually from the ABCs of System Programming, which is a manual I recommend that you read if you're new to ZOS, or particularly new to system programming. The ABCs of ZOS System Programming is a whole series of books, some of which are getting a little old, but they're really contain a lot of good information in them. So we can have the absolute generation name, which we just talked about, which is the GDG base name with the Gulu low level. And the versions could be version 1, version 2, version 99, but only one of those can be cataloged. So when I define a GDG base called abc.gdg, and then as I create the generations, I will specify, I'm going to create generation +1, +2, +3, and the system will be smart enough to create abc.gdg.generation1 version 0, generation 2 version 0, generation 3 version 0, as I create new generations by specifying disposition new. Disposition new always creates version 0. It'll increment the generation number, but the version number is almost always 0 with GDGs. And so we can refer to them by absolute generation number. We can say DSN equal abc.gdg.g0001b00, or I could refer to the generation by its relative generation number. I could say, give me generation 0, abc.gdg.open_0, and that will cause me to access generation 5, which is the most recent. And so this particular GDG I created with a limit of 5. There's a number of attributes that the GDG can have that are defined when I create the GDG base. And so if the limit value is 5, I now have the GDG filled with 5 generations. When I go and create generation 6, generation 1 has to disappear because I've set a limit of 5 to be held in the GDG base, in the GDG sphere record at any given time. And we'll talk about what happens then to generation 1 when I create generation 6. But the advantage of these things is, of course, that I can use the same name, abc.gdg. Whatever the relative generation I'm interested in, +1, -1. So these are the absolute numbers, and on the right are the relative generation numbers. And those can reside anywhere. They can reside on disk, they can reside on tape. In this case, they reside on 2 different volumes. Generation 2 and 5 reside on volume DEF, and the other 3 reside on volume ABC. So what happens when I reach the generation limit? Because I might create new generations every day, 1, 2, 3, 4, 5, and I'll create 6, 7, 8, 9, 10. And if I never do anything about it, I will eventually reach generation 9999 B00. Now, the older generations may not be cataloged in the sphere, but I will eventually reach generation 9999. That's steve.test.gdg.generation 9999 B00. And I go and create the next generation, which I do by saying I want to create disposition new steve.test.gdg, which is my GDG base name, +1. And that will create me, well, I have a problem because I only have 9999 in this low-level qualifier. The low-level qualifier cannot exceed 8 characters. And so what happens? Well, the generation number then wraps to 1. So what we'll actually create, if I have generation 9999 B00, the next generation created is going to be steve.test.gdg.generation 1 version 0. And that logically will follow generation 9999 version 0. So it's treated as if it was generation 10,001, but its actual number is generation 1 version 0. We never create, as we said, we never create a generation 0. You can go out and explicitly create them if you want, but that's not a good idea because it's going to screw up the catalog entries. So how do I know that generation 1 now logically follows generation 9999? There's a flag set in the actually in the generation data set entry that says this is part of a wrap. And so as I create new generations, generation 2 and 3 and 4, they will have the wrap flags on until I once again create generation 9999, and then all the wrap flags get set off, and we begin with generation 1 all over again. So you can have an infinite number, really, of generations, but only 9999 can be actually cataloged at any given time. And so let's talk a little bit, before we get into that, let's talk a little bit about GDG history and where this came from, because GDGs have a really long history. They were originally came about in the 1960s, and they were primarily used at that time for tape and SMF, and actually for general data set use, because there weren't a lot of things that would keep track of cyclical type of data. But they were a little bit primitive by today's standards. 1989, SMS came along. So prior to 1989, you actually had to have a data set, a separate data set defined on the volume in which the GDG was cataloged to provide DCB characteristics. This was quite confusing, and you can still do that, and this is still true for non-SMS GDGs. You need to provide a separate data set to supply the DCB characteristics. And normally that data set is an uncatalogued data set with the same name as the GDG base. So it's a little bit messy. Nowadays, almost everything is SMS managed. In 1989, people came along, they were all dragged kicking and screaming to SMS. But that, for the GDG, was a great thing because it removed the requirement to have a model DSCB. And what's a model DSCB? As we said, it's a data set that's allocated on some other volume, and it's usually a zero-track data set. You allocate it with space equal track comma 0 so that it doesn't take up any actual space in the volume because it's just a place to store DCB characteristics. And so it's therefore called a model DSCB because the only part of the data set that actually exists is the data set control block, the DSCB that resides in VTOC. So the model, so 1989 SMS comes along. The GDGs are somewhat simplified. The model DSCB requirement is removed. You can get the DCB information if you need from like parameters or from the data class. But SMS introduces a new requirement. For non-SMS data sets, non-SMS data sets are always cataloged at the end of the step. They are created, allocated at the beginning of a step, but they are only cataloged at the end of the step. SMS works quite differently, SMS always catalogs everything at the start of the step. And so we have a problem with these GDGs because we've always cataloged them at the end of the step, and now we need a way to catalog them at the start of the step. And but we don't want them to be part of the GDG base yet at the start of the step because we don't know that the step is going to complete. And so for SMS managed GDGs, the generation, as I create a new generation data set, like any ordinary SMS data set, that data set is cataloged at the start of the step, but it's cataloged in a deferred status. That is, it has not yet become part of the generation data group. It's cataloged outside of the GDG sphere record. Only at the end of the step does the data set get recatalogued as part of the GDG. And this has to be done because SMS requires that all data sets be cataloged at start of step, but the GDGs have always been cataloged at the end of the step, and so we have to actually catalog them twice. We catalog them in a deferred status when the step begins, and we recatalog them in active status as the step ends. Over time, long period of time, but over time, there have been additions made to GDG attributes so that GDGs are a lot more flexible than they used to be. If you have an extended GDG, you can now have up to 999 generations in the GDG sphere record. This is something different than the 9999 generation number. The GDG sphere record, the GDG catalog record, has a limit on the number of generations that can belong to the GDG at any one time. And that's always been, for many years, 255 generations at any one time. In ZOS 2.2, they came up with extended GDGs, where we can have a limit of 999 generations cataloged in the GDG record at any one time, as opposed to the generation number, which could be anything from 1 to 9999. And then there are some other enhancements where we can access them in different order, different chronological order, first in, first out, last in, first out. We can automatically roll GDGs that have not been cataloged into the sphere. We can roll them into the sphere, and we'll talk about those as we go on. Okay, so let's step through allocation for just a moment. This is one of the things that DTS has done for many years. We get deeply involved in allocation and the volume processing, where we get a new extent or new volume. And so, as we said, the non-SMS data sets are always cataloged when the step ends. But SMS data sets, the golden rule of SMS is that SMS managed data sets have to be cataloged at the very beginning of the step. And this eliminated a lot of the old not cataloged to problems that used to have. But it generated a little bit of a problem for GDGs because GDGs are expecting to be the catalog record, the GDG record, is built such that it expects the GDG to be cataloged at the end of the step into the sphere record. But if it's an SMS managed data set, we have to catalog it at the start of the step. So we have our data set. In this case, I call it wwcsjp.gdg +1. I want to create a new generation, disposition, new catalog. The first thing that happens in allocation is there's an enqueue on the GDG base name. That is, we enqueue on wwcsjp.gdg so that no one else can create a new generation while we are running. I can really only have one job accessing or creating a new, I have multiple jobs accessing generation data sets in the same generation data group, of course, but I can only have one that's going to be creating new generations at any given time. And so we allocate the absolute generation, generation whatever version 0, because it's you can't use the system is always going to create version 0, and so we'll allocate this absolute generation. So if the current generation, that is the most recent generation in the GDG sphere entry, is generation 1000, when I create the +1 generation here, it will create generation 1001. It'll allocate G1000, B00. But it would be relative generation number +1 for the duration of the job. So if I want to create 2 or 3 or 4 generations in the job, I will refer to them in the job as generation +1, +2, +3, and the something called the past dataset queue is built that will keep those generations, keep referring to those generations they'll keep referring to those generations by the same number. So we initially catalog it outside of the GDG as deferred. We may obtain the DCB characteristics either from a model DSCB, which can't really be used for SNS, but from the DCB parameter, or from the data class, or from a like parameter. We'll open the data set, presumably process it, do something with it. If this creation of the next generation, generation 1001, caused the GDG limit value to be reached, which is the limit value is how many generations can belong to this GDG at any given time, then the oldest generation is going to be removed. It will be removed from the GDG sphere record, and it may be deleted. So now at the end of the step, we're going to catalog the sphere as active, catalog the GDG record, the GDS in the GDG sphere is in active status as opposed to deferred status, and then finally we'll DQ the GDG. And so this is the creation of a new data set, or a new generation data set. Now I said we're going to create generation +1 here, and that's relative to the start of the job. So if I want to create 3 or 4 data sets, 3 or 4 GDG generation data sets, in the JACL, I have to call them +1, +2, +3, and I have to refer to them in that way regardless of what step I'm in. So I can't create +1 in the first step and then in the second step create another one and still call it +1. I have to call it +2 normally. Recently, fairly recently, within the last 5 or 10 years, there's a new parameter called GDG bias. This is a JCL parameter, and I can say GDG bias equal job start or step start. The default is job start, which says the relative GDG number is relative to the start of the job. So if I create a +1 generation and I have 100 steps in the job, and I want to refer to that generation in the last step, I still have to call it the +1 generation. Whereas I could say GDG bias equals step, in which case that relative number, +1, +2, +3, refers to the relative generation as the catalog exists at the start of that step. So it's a little bit confusing, but the relative generation number that you have to specify can refer to the relative generation in the catalog. This is the new +1 generation, the +2 generation, or the -1 or -2 if they're referring to an older generation. It refers to the relative generation in the catalog. How far is it from the most recent? Based upon the catalog as it existed either at the start of the job or at the start of the step. And normally it's always GDG bias equal job. There are very few cases in which people will code GDG bias equal step because, again, history has a long arm in ZOS. And if you're going to change JCL, not a lot of people, I think, taken advantage of GDG bias equal step, but it is available. Okay, so let's talk about the components of a GDG, the GDG attributes. If I do an ID cams define, I only really have to specify 2 things. The GDG name, the base name, wwcsjp.gdg, or whatever I want to call it, my GDG, and the limit, which is either going to be, which has a maximum value. That is, how many generations can this GDG keep track of? I could potentially keep track of 255 generations for an ordinary garden variety GDG, but maybe I know that I only ever need to keep 10 generations cataloged at any given time. So it makes sense to specify, you have to specify a limit. You could specify a larger limit than you need, which provides some room for expansion, but you may leave data sets around longer than you might like to if that's the case. However, you might need more than 255 generations And so in ZOS 2.2, they allowed you to specify a new limit of up to 999 generations. And then, of course, people began specifying 999 generations and keeping that many around. And maybe that wasn't such a good idea. And so now there's a system limit, keeping with the sort of ZOS principle that for every parameter, there's an equal and opposite parameter. The limit value of 1 to 9999 for an extended GDG, or actually the limit, any limit value you specify, is subject to a value in sys1 parmlib in IgG cat 00 that says GDG limit max equals whatever. So the system programmer can say, yes, I know the maximum value for an extended GDG is 999, but you can't specify that because I said GDG limit max equal 500 in my sys1 parmlib IgG cat 00. So the limit, which is the maximum number of generations I can keep cataloged at any one time in the GDG base, which is different, as we said, from the generation number. And so we have a bunch of other parameters, but only a few of them. And they're pretty easy to understand. It could be extended or not extended, which means I can specify a limit of 255, or if I say extended, I can specify a limit of 999. Because extended GDGs actually have a different type of catalog entry, I cannot make a GDG extended merely by changing the limit. I actually have to delete and redefine it. But when I do define a GDG, if I want to have more than 255 generations, I've got to define it as extended. I can say what happens when I fill up the GDG limit. That is, if I've got if I set a limit value of 10, what happens when I create generation 11? Well, normally, if I take the default of no empty, when I create generation 11, if the limit is 10, when I create generation 11, then generation 1 is going to become uncatalogued if it's SMS managed. And it will simply sit out there uncatalogued. Or excuse me, if it's not SMS managed, it will simply sit out there uncatalogued. If it's SMS managed, we cannot have an uncatalogued data set. SMS abhors uncatalogued data sets. And so if I take the default of no empty, that is, don't empty the GDG, when I create a generation that exceeds the limit value. So if I have a limit of 10, I create generation 11. Or if I have a limit of 10 and the current generation is 22 and I create generation 23, anything that will cause the limit value to be exceeded, the older generation either gets uncatalogued if it's SMS managed or rolled off if it's uncatalogued if it's non-SMS managed, or rolled off if it's SMS managed. And by rolled off, we mean the data set is uncatalogued from the GDG base. It no longer is part of the GDG, but it is recatalogued individually. So it has the same name, base name .g00g xxxx vxx, but it is cataloged outside the GDG sphere. So the default is just to roll off the oldest one. But if you specify empty, when I reach that limit, if I've got a limit of 10, I create generation number 11, then all of the old generations will be deleted, and I only have one in the cat. All of the old generations will be deleted, and I only have one left in the GDG. So suppose I uncatalogued it or rolled it off. Would I really like that data set to stick around, or should I just get rid of it? If it was rolled off by virtue of empty, no empty processing, that is, I created a new generation, I've reached the limit, the oldest generation has to be kicked out of the GDG. What do I do with that generation, or all the generations that were kicked out of the GDG? The default is nothing, no scratch, don't do anything with them. But if I specify scratch, then I will delete all of the uncatalogued or SMS rolled off generations that were created as a result of the limit being exceeded. That obviously applies only to DASD because you can't scratch a tape. You could scratch a tape data set, but there are many other complications involved with that. What order do I want to see them in? For many years, you always had to do them in reverse order. The last, if you specified just the GDG base in the JCL, that means that's what's called a GDG all request, which means I want to see all of the generations belonging to the GDG, all of the generation data sets, as if they were concatenated together. And they are concatenated together in reverse order, the oldest, the newest generation first. But I can specify FIFO, where the oldest generation will be first. And then there's just a couple of other parameters. What do I do about generations that have an expiration date? Particularly for tape, I might have given them an expiration date. If I'm going to scratch them as a result of them rolling off, should I override the expiration date? Actually, it applies to DASD because well, it applies to tape for uncataloguing, but if I'm going to override the expiration, should I override the expiration date so that I can scratch the data set? Okay, and then you can specify an owner ID, which is sometimes abused. So when I look at a generation data set, not the generation data group, but when I look at the catalog entry for a generation data set, it can have one of three statuses in the catalog entry. It can be deferred, which means I started the job step, the data set was cataloged outside the GDG sphere, but for some reason, I never got to end the step. I never got to roll it into the GDG. I have a GDS, but it's sitting out there not belonging to the GDG. That can happen as a result of end of step failure, or you can actually cause it to happen deliberately if you just go disposition new keep rather than new catalog. And so if I have these data sets that for some reason, maybe my job failed, are sitting or cataloged outside of the GDG sphere, there is an IDCAMS statement. I can issue an IDCAMS alter, whatever the base name, alter the generation data set name, say alter roll in, which will cause that generation that is now cataloged outside the GDG to roll into or be cataloged within the GDG, and now it counts against the limit. Since it didn't count against the limit because it was if the step failed because it never got rolled into the GDG. And the active generations are those that are part of the GDG, and then the rolled off generations, as we just saw, are those where I created new generations, but I've reached the limit. I can keep creating new generations, but the older generations will roll off. And they could be in rolled off status, unless I specified scratch, in which case the rolled off generation actually got deleted when it rolled off. Okay, so we talked about GDG all processing on LIFO or FIFO. If I specify just the DSN equals whatever the GDG base name is, then all of the active generations are treated as a single data set. They have to be treated as a single concatenated data set. So the concatenation order can be either FIFO or LIFO, depending upon what you specified when you defined the GDG. Or if you didn't specify anything when you defined the GDG, the default is LIFO. So in that case, the concatenation looks like generation 6, 5, 4, 3, 2. This is a GDG where I've got 5, 1, 2, 3, 4, 5, limit of 5. And so they're treated as all one concatenation. One DD name called, in this case, DD all. But if I'd specified FIFO, I would get them in different chronological order, oldest to newest, so 2, 3, 4, 5, 6. I can actually, so it depends on whatever you specified at the time you created the GDG, FIFO or LIFO, or there is a parameter in JCL where you can specify this. The default is GDG order, which says whatever the GDG defined said, FIFO or LIFO, or you can actually specify GDG order equal FIFO, GDG order equal LIFO. I want for a GDG all, where I'm specifying just the base name, I want the concatenation in either FIFO or LIFO order. Okay, so if we go to define a GDG, the define statement is pretty straightforward. It's just define GDG, we give it a name, we give it a limit, and we give it possibly some other parameters, scratch or no scratch, empty or no empty, extended or not extended. So in this case, it's a limit of 5. I have a relative. I now have in this case, an IFPR 14 step that's going to create the first generation belonging to that GDG. And so the relative number is +1. If I then list cat that GDG, we'll see that the GDG base name is wwcsjp.gdg. Here are all its attributes. What's the limit value? No scratch, no empty, LIFO. And it's associated with, there's an association record in the catalog of www.csjp.gdg. And the Google level is generation 1, version 0, because I've just created it. As I create generation 2, 3, 4, 5, 6, the generation number will increase until I get to generation 9999. So as I'm processing these generations, if I run another job where I'm going to create generation +1, and then the next generation I want to create is going to have to be +2, +3, +4, +5, I create 5 additional generations, then the generations that are going to be created are wwcsjp.generation 2, 3, 4, 5, 6. Okay, now this 2, 3, 4, 5, 6, I've created 5 generations here. What happens to generation 1? Well, generation 1 is rolled off, because if I do an ISPF 3.4 and I look at the catalog, we can see that I have the GDG base name in the catalog, wwcsjp.gdg, and all 6 generations are cataloged. But if I do a list cat of this GDG, I will only see generations 2 through 6. Generation 1 is cataloged, but it is cataloged outside of the GDG sphere record. It has rolled off. And so if we looked at the catalog entry for generation 1, we will see that it's in rolled off status. And let's see, and it's on, I've forgotten why I put this other one in here. Yeah, it's in rolled off status. Oh, and it does not have any association cell. So the non-VSAM entry, the catalog entry for generation 1, is in rolled off status, and it's not associated with the GDG base. Whereas the non-VSAM catalog entry for generation 6, which is the last one I created, which is currently relative generation number 0, has a status of active, because when it was created in deferred status, and then it was rolled into the GDG, and it is associated with the GDG. Okay, let's see. There is something called GDS reclaim, which is a system-wide parameter that's useful if when I create a generation, I'm unable to roll it into the sphere for some reason, the step fails, and the roll-in feature, which you can turn on, which is normally turned on system-wide, allows you to take that data set that's in deferred status, and rerun the job, and it will reuse that data set rather than create a new generation. And so GDS reclaim is used when I need to run another job. I've run a job, it's failed to get the end of step, failed to roll a deferred GDG into the deferred GDS into the GDG sphere. If GDG reclaim is enabled, which normally it is, I can, rather than create a new generation, I will simply roll that existing generation into the sphere. Okay. I can do IDCAM's alter on GDGs. I can alter the GDG base. You can do an alter on the generation data set, but really the only thing you can alter is the name. I can do an IDCAM's alter on almost anything in the GDG base. I can give it a new name if I want, if it's empty. I can change the limit, and reducing the limit value will roll off generations, just as if I had had a smaller limit to begin with. Increasing the limit value will roll in any rolled off generations. I can change from scratch to no scratch or empty to no empty and so on. So IDCAM's alter can be useful if I need to change the characteristics of a GDG. Extend the GDGs, as we said, the limit value is now increased to 9999. which means they actually had to change the catalog record. The catalog record for an extended GDG looks a little different. It's got a 2-byte limit field rather than a 1-byte limit field. And so if you're using the catalog search interface, there's a couple of fields you can reference to find out whether it's data set's really a GDG, extended GDG, and what the limit value is. And so, but as we said, changing the limit value doesn't change the GDG format. I can't simply say limit 999 on an alter. I can't alter a GDG from limit 255 to limit 999 because I have to actually change the GDG itself. So if I want to convert a generation data group to a generation data group extended, I have to go through a little bit of a process. I basically have to delete the old one and recreate a new one. But I don't actually have to move any data. All I have to do is recatalog things. So if I have my GDG called wwc.sjp.gdg, and I want to make that an extended GDG, what I can do is create a temporary GDG called wwc.sjp.gdg temp, with whatever my limit is. And then I can rename all of the old generations, and this is the sticky part. Excuse me, I have to rename all of the old generations so that they now belong to the new GDG, to the new temporary GDG. But I can move generations from one GDG to another just by doing a TSO rename. Then I delete my original GDG. I define my new one. I probably didn't want a limit of more than 10. If it's extended, I probably wanted to go to 500. But I define my, that should say, I should delete GDG. That should say GDG and not GDG temp. I define my new one as extended. And then I rename all of my my generation data sets that I renamed from GDG to GDG temp. I rename them back to GDG so that they're all back in the original, now extended GDG, and then I can delete the temporary. So it's actually a fairly simple process to convert a GDG to an extended GDG to have a larger limit value. The trick being you've got to uncatalog and recatalog all the generations belonging to that GDG. If I want to delete a GDG, I probably want to delete all the generations first. And so the easy way to do that is simply say delete, and I use the mask value or the mask parameter in IDCAMS to say I want to delete anything that might have a GUVU low-level qualifier, wwc sjp.g, and the percentage is a mask, a single character mask. Override the expiration date, which will get rid of all of the generations, but not the GDG base. If I want to get rid of the GDG base, I need to say delete wwc.sjp.gdg, and I specify the GDG parameter to delete the base. And if I haven't done this first statement, the GDG is non-empty, I have to specify force. And then we'll see that each entry, it's an A-type entry for an ordinary non-VSAM data set. It's deleted, and then the B-type entry, the GDG base itself, gets deleted. Okay, there are some sys1 parm lib settings that allow you to specify, or that are pretty much that are system-wide. In IGD SMS00, you can say I do or do not want to do GDS reclaim. In IGG cat00, which is where most of the GDG parms are, you probably want to enable GDG extended equal yes, otherwise you won't be able to create extended GDGs. You want to allow users to specify FIFO or LIFO. What's the ultimate limit for GDGs? Do you want to allow users to specify purge? So there are some system programmer settings in IGG cat00 that have to do with GDGs. And then finally, just a couple of examples here, which I won't really go through. You can use something like our ACC product to get in front of an IDCAMS define and define a GDGE rather than a GDG. So I have a rule here that says if it's a data set name of interest and I'm doing a GDG define, then I can automatically set extended format or extended GDG and set a limit value and set empty and purge. So I can, with ACC, for GDGs, just like any other data set, I can establish system standards within what are now the sync sort storage management products allocation control center that will enforce system-wide standards for limits and whether or not I'm creating a GDGE and scratch and empty and so on. And so where is all this documented? The place to look is using datasets, chapter 29. And there is some information on tape GDGs and using magnetic tapes. There's lots of really good examples in the JCL Users Guide and in the ABCs of a nice overview of GDG processing itself in the ABCs of the OS system programming. But probably the main place to look is in chapter 29 of DFSMS using datasets. Next month's webinar will be in November. It'll be actually coming up pretty quickly. November 5th, I believe, is the date. And we're going to talk about catalog, a little bit more about catalogs. GDGs are one type of catalog entry. We'll talk about other types of catalogs and catalog entries and how they get used. The DTS software products, as we've said, are now part of sync storage management. So if you want to find things out about the DTS products or about the DTS webinars, you can now go to SyncSort, and if you need support on our products, we're still here, but you need to open up a support case with Precisely, we now do everything under the Precisely banner, but we're all still here, and we're all still supporting the products we've supported for many years, just with more resources than we used to have. And so at this point, I've run most of the hour, but I think we have a few minutes that we can maybe run a little over, and we can talk about questions. And so I'll turn it back over to you, Ray, and see if we have any questions on or that sort of thing. One thing I should mention is that we will send out copies of this webinar, and I guess, Ray, you can talk to that.
Yeah, at the moment, there are no outstanding questions. As Steve mentioned, we are recording this session, so we'll send out a link to the recording once we're done. And then also, I believe we're sending out a copy of the slide deck as well.
I look forward to seeing everyone next month, fairly soon, where we'll talk about catalogs. And if you find this useful, certainly tell your friends and colleagues. We would like to continue these DTS webinars, particularly we think they're particularly useful for folks that are relatively new to ZOS, and we would like to sort of spread the word a little wider. So we're interested in any questions you might have, not only about the webinar topic itself, but anything to do with storage management or problems you've got in your environment that potentially we could look at and maybe provide a means of solving. This is always really useful for us because we live in a little bit of an ivory tower here. We know what we think people want. It's always, sometimes what they want is quite different. And so I'm really interested in hearing from anyone that would like to talk a little bit about storage management or system programming or issues they're running into in their shop.
Well, thanks everybody for attending. Yep, still no new questions. So yeah, again, thanks everybody for attending. We'll see you at the next one. And I think this is probably a record, 2 minutes early.
Great. All right, thanks everybody. We'll see you on November 5th.